All right, so in the last section, we talked about graphing the sine function, the cosine function. And the cosine function is really the sine function just shifted. Let's talk about the tangent function. We're going to talk about the tangent, the cotangent, the secant, and the cosecant functions. So the tangent, the cotangent, the cosecant, and the secant functions. All right, let's take a look at y is equal to the tangent of x. So we have our angle, 0, and the tangent is 0 at x equals 0, right here. And the tangent is 0. Then we do pi over 6, and we get the square root of 3 over 3, which as a decimal is 0.6. Normally I don't recommend decimals, but there's a reason why. So then we do pi over 4 and pi over 3, and we get 1.7. So we go from 0 to 0.6 to 1 to 1.7. Now we're going to, so you know this is 30 degrees, this is 45 degrees, this is 60 degrees. The next one is 75 degrees, and there's a bigger jump here, 1.7 to 3.7. Then we go to 85 degrees, and there's a much bigger jump, and 89 degrees, and there's a really big jump, and this is very close to pi over 2, but it's not pi over 2. And notice we have a huge jump here. So what's happening? So we start out with a fairly slow increase, and then as we get closer and closer to pi over 2, the increase gets steeper and steeper and steeper. So we start at 0, and as we approach pi over 2, it gets steeper and steeper and steeper. Now we do have an asymptote at pi over 2 because the tangent is undefined at pi over 2. And if you look at the negative angles, so negative pi over 6, negative pi over 4, negative pi over 3, it would be a negative tangent, or the tangent would be negative, sorry. And so again, it would get steeper and steeper as we get closer and closer to negative pi over 2. And again, we have another vertical asymptote at negative pi over 2. Because, remember pi over 2, tangent is the sine over the cosine, and the cosine is 0 at pi over 2, negative pi over 2. So that would make this undefined. That would make the tangent undefined. Okay. It is an odd function, so it is symmetric with respect to the origin. So if we go up like this, then it's going to have the same sort of shape going down. And it's undefined at pi over 2. Okay. With the sine and cosine, sine of x and the cosine of x, those both had a period equal to 2 pi, but the tangent has a period of pi, okay? So it's pi units long. It doesn't mean it starts at 0 and goes to pi, it means that it's pi units long. So if we have the distance from here to there, that's pi over 2 units. And then from here to there, that's also pi over 2 units. So if we add those, we get 2 pi over 2, which is pi. So what we have right here is a single period drawn for the tangent function. Okay, the domain for the tangent function All right, let's go back to the sine and the cosine. The domain for the sine and the cosine was all real numbers, negative infinity to positive infinity. But because we have these asymptotes where the cosine is equal to 0, then we can't have that in the domain. And rather than listing out every single one of them, which is impossible because there's an infinite number of them, what we just say is all real numbers except for odd multiples of pi over 2. Why do we say odd multiples of pi over 2? Well, 1 pi over 2 has a vertical asymptote here. But if you look at 2 pi over 2, that's an even multiple of pi over 2. That's pi, and that's fine. It's 0. Tangent is 0 at pi. And then we add another pi over 2. And that's right there. We add another pi over 2, so now we have 4 pi over 2. That's 2 pi, and that's perfectly fine. We have the tangent is equal to 0 at 2 pi. So it's just the odd multiples, the 1s, the 3s, the 5s, -1, -3, -5. The range, so the range actually is all real numbers. It starts down here at negative infinity and goes up to positive infinity. Again, vertical asymptotes at odd multiples of pi over 2. You are going to have an x-intercept that's halfway between each pair of consecutive asymptotes. Okay, so if you look at negative pi over 2 and positive pi over 2, exactly halfway between is 0, and there is an x-intercept there. If we look at pi over 2 to 3 pi over 2, exactly halfway between is 2 pi over 2, which is pi, and there is your x-intercept. And so you can just keep on going with that pattern. It is an odd function. Okay, so when we have points that are 1/4 and 3/4 of the way between consecutive asymptotes, you're going to have a y-coordinate of -1 and 1. Okay, so right here, halfway between, and right here, halfway between. So if we have an x of 0 and an x of pi over 2, halfway between, so halfway between is pi over 4. So here at pi over 4, you're going to have a y value of 1, and then negative pi over 4, you'd have a y value of -1. And it works for all of them. Halfway between 2 pi and 5 pi over 2 would be 5 pi over 4, and that's right here, and there's your 1, etc. Okay, so how do you graph the tangent? Well, first thing you do is find 2 consecutive asymptotes by putting this right here between pi over 2 and negative pi over 2 and solve. So next thing you want to do is find your x-intercept. Your x-intercept is going to be halfway between the 2 asymptotes that you just found, and then 1/4 of the way between, then you are going to have y values of -a and a right here, and that will give you 1 full period, and you can keep, you can draw as many periods as you like. All right, so bx minus c is equal to pi over 2. Bx minus c equals negative pi over 2. The y value is going to be negative a, and the y value is going to be positive a, and again, this is a quarter of the way, or halfway between the x-intercept and the asymptote. Okay. I'm not sure what that blank page was all about. Okay, so we want to graph 3 times the tangent of 2x, and we want to graph it between negative pi over 4 and 3 pi over 4. So first thing we have to do is determine a, b, and c. Okay, and we need to find 2 consecutive asymptotes. So we have negative pi over 2 is going to be less than bx minus c. Okay, so we replace this with this. So negative pi over 2 is less than 2x is less than pi over 2. And we divide everything by 2, which is equivalent to multiplying by 1/2. So negative pi over 4 and pi over 4. So 1 full period is going to be between negative pi over 4 and pi over 4. And we're going to have 2 consecutive asymptotes at x equals negative pi over 4 and x equals pi over 4. If we want to be exactly halfway between, so we're going to have an x-intercept halfway between negative pi over 4. So here's my negative pi over 4, and here's my positive pi over 4. And halfway between would be x equals 0. So we're going to have an x-intercept at 0, 0. I'm not sure what's the deal with these blank pages. Okay, so we also need to find halfway between. So here's my negative pi over 4, and here's my positive pi over 4. And here's 0. So I need to find this right here. So halfway between here and here, there's a couple different ways you can do this. But if you add them together and then divide by 2, you get pi over 8. So this would be pi over 8, and this would be negative pi over 8. You're going to have a y value of negative a and a. So at negative pi over 8, you would have a y value. My a was, what was my a? I don't remember. A was 3. So my a is 3. So negative pi over 8, we would have a y value of negative 3. And then positive pi over 8, you would go through a positive 3. All right, let's take those points that we know and All these weird blank pages. Okay. Okay, so we have, I'm trying to remember, pi over 4. There it was. Asymptotes at negative pi over 4, pi over 4, and then that's one period, and then we could keep on going if we wanted. So that would be another period. In the middle, halfway between, you're going to have an x-intercept. In the middle, halfway between, you're going to have an x-intercept. Halfway between that, you're going to have a point at negative 3. And halfway between that, you're going to have a point at positive 3. And it's going to go something like, yeah, this is a really bad graph. Yeah. Okay, well, it's not a straight line. It's supposed to go up. Where's my 3? Ignore that. Okay, so it's supposed to go up, level off, and then go back, curve, and go up again. That one was better. Anyway. Okay. Cotangent. So cotangent looks very similar to tangent. A couple differences. Well, first thing, the period is pi, and the domain real numbers except multiples of pi. So pi, 2 pi, 3 pi, 4 pi, 5 pi. And instead of, going up, across, and up, we're going to go down, across, and down. And this one quarter of the way is going to be a positive 1. This one's quarter of the way is going to be a negative 1. And again, halfway between is going to be an x-intercept. Already talked about vertical asymptotes. Already talked about the x-intercept. It is an odd function. And I already talked about a quarter of the way. Okay. To graph two consecutive, or to find two consecutive, to graph the cotangent, you find two consecutive asymptotes. This time, instead of between negative pi over 2 and positive pi over 2, you go between 0 and pi. But otherwise, it's the same. 0 and pi. Halfway between, a quarter, that's going to give you a positive A, a negative A, positive A, and negative A. And that will give you one period. Okay, so here's a nice, pretty graph of all the information that you need. Okay, let's see. We need to graph y equals 1/2 cotangent pi over 2 x. Okay. So first thing we need is two consecutive asymptotes. So let's do our A, B, and our C. A is equal to 1/2. B is equal to pi over 2. And C is equal to 0. So here's my 1/2. Here's my B. And that's plus 0. Right? Okay, so 0 is less than bx minus c. So pi over 2x plus 0. Multiply both sides by 2 over pi. I said both sides, I meant all three sides. 2 over pi, that will cancel. This gives me 0, and those will cancel. So we have 0 is less than x is less than 2. So there's going to be one full period between 0 and 2. So we're going to have asymptotes at 0. ASYMPTO at x equals 0 and x equals 2. And then an x-intercept halfway between 0 and 2 is x equals 1. So it's going to go through the point 1, 0. What else do we need? Okay, we need a quarter of the way in between. Okay, so we've got 0 and 2, halfway between is 1. So my quarter of the way is 1/2 and 3/2. So that's where I'm going to have my positive A, and this is going to give me my positive A and my negative A. And A again was 1/2. So I'm going to have a point at 1/2, 1/2. I'm going to have another point at x equals 3/2 and y equal negative 1/2. Okay. And I think that gives us enough information to graph it. To be honest, those labels are not good. I'm going to relabel those. Let's label this as 1, 2, 3. And we had asymptotes at 0 and at 2. And an x-intercept at 1. And then halfway between, right here. So this is 1/2. This is also 1/2. And here's my negative 1/2. This is my 3/2. So it's just halfway between 1 and 2. And let's see if I can draw this. So that would be 1 period. The cosecant. And the secant. Remember, the cosecant is the reciprocal of 1 over sine, and the secant is 1 over cosine. So to get the graph of the cosecant, we're going to do vertical asymptotes at all the x-intercepts of sine. Why? Because it would be 1 divided by 0. That's undefined. For the secant, it would be vertical asymptotes at the x-intercepts of cosine for the same type of reason. Okay, so because it's reciprocal of the sine and the cosine, the period is going to be 2 pi, just like the sine and the cosine. Let's see. Here is the sine function right here. Here's my sine function, right? And so we have an x-intercept here, an x-intercept here. If we take the reciprocal of 0, it's 1 divided by 0, and that's not allowed. So here's going to be my vertical asymptote, and there. and keep doing multiples of pi. And then it's going to be 1 here, and it's really hard to describe how this comes about without doing a table, but the cosecant graph, there would be 1 period right there. So I need both of these to have a period. Okay. So the easiest way to draw the cosecant is to first draw the sine and then do your U shapes. Secant works the same, only with the cosine graph. So the cosine graph also has a period of 2 pi, but it goes through, it starts at 0, 1, and then goes like that. Okay, so it still has a period of 2 pi. I'm going to have asymptotes at odd multiples of pi over 2, because that's where the x-intercepts are for the cosine graph. Okay. So use the graph of sine of x plus pi over 4, which we learned how to do in the last section, to obtain the graph of the cosecant, which is the reciprocal. So anytime we have an x-intercept, that's going to give us vertical asymptotes, like that. And this is going to be the bottom of my U, and then it's going to get closer and closer to those vertical asymptotes, like that. You could plot a couple points if you wanted. And then this is going to be the top of my, I don't know, what's an upside down U? There you go. This would be the bottom. It's going to go around like that. So basically, how do you graph the cosecant? Well, you graph the sine first, and then draw your U shapes. I already graphed it. We already graphed it on the last slide. Okay. Graph 2 secant 2x. Okay, secant is a reciprocal of cosine. So what we're going to first do is graph y equals 2 cosine 2x, with a is equal to 2, b is also equal to 2, and c is equal to 0. Because it's the cosine, our period is going to be 2 pi divided by b. So our period is 2 pi divided by b, which gives me pi. We are going to cut that into 4 equal sections. So each section is going to be pi over 4. So my first one is going to be 0, pi over 4, add another pi over 4, gives me pi over 2, another pi over 4, another pi over 4. So we're going to evaluate for those x values. I just use the table function. Okay, so those are points. Okay, here we go. So pi over 4, 2, this is going to be negative 2. 3 pi over 4 is going to be 0. Okay, so here is my cosine graph. So my secant, I'm going to have asymptotes there, any x-intercept. Okay, and there. And let me see if I can change colors here so I can draw the secant. Okay, so this is going to be the bottom of my U. So it's going to go like this. And the top of my U, so it's going to go like that. And I don't, oh, they said between negative 3 pi over 4 to positive 3 pi over 4. Oh, we didn't go far enough. Negative pi over 2, negative 3 pi over 4. So I need another asymptote. And let me switch back over to the blue. It's going to be down here. It's going to be here. Okay, so now I can finish my secant. So my secant is right there. All right, so that would be 2 secant 2x. Okay, these slides are, well, they're not examples, they're just kind of like summarizing all of the graphs of the trig functions. So we have the sine, cosine, tangent, cotangent. This one's cosecant and secant. And then lesson reflection.